My talk is entitled Future Differential Vulnerability to Natural Disasters by Level of Education. And what I'm planning to do in this, what I'm trying to show in this presentation, first of all, is a brief summary of the shared socioeconomic pathways and what Wolfgang called in his opening presentation the human core of those SSPs. These SSPs, as has already been mentioned, are supposed to replace the previous IPCC's special report on emission scenarios, which have so far been used for assessing future levels of emissions. But in contrary to these stress scenarios, the SSPs are much more detailed on the population heterogeneity, and they include the full population detail by age, sex, and also educational attainment. But what's important here also is why are they called the shared socioeconomic pathways? Because the idea behind creating these scenarios through the global integrated assessment modeling community was to provide a common framework for assessing future developments as diverse as future output growth or human development, as Jesus is going to talk about in this session, or urbanization, as Lewin has shown in some of his previous work. So I want to just briefly talk about the 5 different SSPs, and then in part B, I want to use previous work that I've done together with Wolfgang and Anthony Patt, another colleague from YASA, on the socio-demographic determinants of differential vulnerability to natural disasters, and eventually the aim is to apply the B on the A. So show what these shared socioeconomic pathways mean in terms of differential vulnerability to natural disasters. But first, let me just briefly remind you of the shared socioeconomic pathways. This picture, Wolfgang already showed it at the beginning, shows you the adaptation mitigation space. So the further we go to the right on the x-axis, the adaptation challenges increase. The further we go up on the y-axis, the mitigation challenges increase. What you have here in the center is the so-called middle of the road scenario, which in demographic terms corresponds to medium assumptions for fertility, mortality, and migration. And of course, this also leads to intermediate challenges for both adaptation and mitigation. In the lower left corner, you have SSP1, where both challenges to adaptation and mitigation are minimized. This is in a way the most optimistic scenario, where we experience a global reduction in inequality. This scenario is also, has also been labeled the sustainability scenario to distinguish it especially from SSP5, which I will talk about just in a moment, which is conventional development. The sustainable development in SSP1 will be accompanied by a rapid expansion in educational attainment, which will lead to a high rate of technological progress, a rapid demographic transition, and as a consequence of that, comparatively small overall population level. If we look at the upper right corner of the picture I just showed you, we have the SSP3, which is like the extreme other end. So this is the most pessimistic scenario, also called fragmentation, because in this scenario we experience a very divided world, where both the mitigation and the adaptation challenges are maximized in comparison to the other scenarios. And this is also a consequence on the demographic side of a stalled education transition. Very little progress is made as a consequence in the demographic transition, which means that we have very unevenly distributed population growth. So especially the high fertility countries of today will continue to grow very rapidly, and world population will reach its maximum in this scenario. Needless to say, for the lack of cooperation in this very fragmented world, migration is not going to play a big role in SSP3. SSP4, on the other hand, is quite similar to SSP3, but it is less challenging in terms of mitigation, although equally very challenging in terms of adaptation as well. This is simply because a large fraction of the world population in this scenario is left behind in abject poverty with very low levels of education. And this is, of course, going to have a similar effect on the demographic transition. It will also stagnate, and we will see higher levels of population growth from today's developing world. But what's important here is that a large fraction of the global population in this scenario will be left behind, and due to their very small income, they will not even dispose of the means, of the necessary means to make a large contribution to CO2 emissions, for example. And therefore, mitigation challenges will be rather smaller. But since these people are so poor in this scenario and less educated and have a smaller ability to cope, the adaptation challenges are still very high in this scenario. And then finally, we have SSP5 in the upper left corner, which corresponds to conventional development. So this is pretty much a scenario where more of the same, meaning more economic growth, is supposed to lead to the solution of all problems. But of course, even though this leads to continuous growth in all parts of the world, and the poorer countries catch up to some extent, it is also much more challenging in terms of mitigation, because these formerly poorer countries will also catch up to the consumerist lifestyles that we see in the richer parts of the world today. So this fast economic growth throughout the world, which is happening not in a sustainable way, drives mitigation challenges. Education, on the other hand, will be expanding. As a consequence of that, we will not see so strong population growth, but this is also because it will be increasingly challenging for the people in today's developing world to mitigate or to bring together family and work. So they will be very much challenged by the same challenges as the OECD countries already today. The overall effect on world population then is mixed. Here you see a more detailed picture of what these 5 SSPs translate to in terms of overall population in thousands. These are 6 major world regions, not 5, sorry for that. I had to put them on different scales because most of the action in terms of population growth here is going to happen in Africa and Asia. And you would not really see much change in the other regions if you were to put them on the same scale. But this is pretty much just to show you how large a range of different results in terms of overall population we get from these SSPs. But of course, not just overall population changes, also within these societies, the different SSPs lead to very, very different kinds of distributions. So you see as an example here Africa in 2100. The 5 SSPs next to each other. As you can see in SSP1, some of you might probably wonder why SSP1 and SSP5 look so similar, but the simple reason for that is that these 2 scenarios are only different, for Africa at least, with regard to migration. And since in any case a maximum of 25% of one cohort can migrate, and in these 2 scenarios, future generations are going to be smaller because of the lower fertility. Migration is not going to have such a huge impact. Well, it will have a big impact, but this is remember that this is the aggregate of Africa, and a lot of the migration is actually happening within Africa, and so this difference in migration does not really amount to such a large overall difference in these pictures. SSP2 is the middle of the road, so that corresponds to the central scenario in the Wittgenstein Center's population projections by age, sex and education. And then you have the fragmentation scenario where you have a disaster right there, where you have an enormous fraction of the population left behind, in red here with no education at all. Orange is primary education, and then you have some people already with secondary and even tertiary education, but in comparison to SSP1 and SSP2, that share is rather small. SSP4 is quite similar to SSP3. It reaches a slightly lower level of population in Africa, but you can see the inequality here is bigger. You see that the blue parts are bigger, meaning more people have already a tertiary education, but at the same time also there are more people who have absolutely no or only primary education. This brings us to part B of my presentation, where I want to start out with the question of how to save many lives, and on top of that, even quite some money. In its World Synthesis report, the World Bank in 2010 has estimated the adaptation cost due to climate change the annual adaptation cost due to climate change at around $70 to $100 billion. This large uncertainty about the exact cost also reflects the large uncertainty about the exact effect climate change is going to have in specific locations. Because in fact we still know very little about where exactly what is going to happen at which time. And this, of course, poses a challenge for investments into climate protective infrastructure, because, of course, this is a lot of money, and especially in times of economic hardship, financial crisis, the global community has to think very thoroughly about where to invest that money. And so the idea is not new, that rather than focusing on very specific interventions that would only have a benefit if climate change really plays out in one particular predicted way, instead of investing in these very specific interventions, one should rather focus on increasing the general capacity of future societies to adapt to a changing climate. So as a consequence of that, you already have a vast body of literature, which I'm not going to talk about in much detail, which is integrating these adaptation strategies into broader strategies of development. But it is quite remarkable that none of these studies is really looking at education as a possible intervention in particular. So why do we think that education, or why do I think that education has such a strong impact? Well, Wolfgang has already talked about this in his opening remarks also. It leads to empowerment, particularly for those who are most disadvantaged, and as a consequence of that also most vulnerable to climate change, and thus reduces inequality. Education, if you're able to read and write, it also leads to better access to relevant information, but also cognitive skills are enhanced, and it leads to, as studies have shown, it leads to less risky behavior. We have seen in several studies, for example in Emilio's presentation, how risky behavior can cause a lot of excess death. But it also leads to a longer personal planning horizon, which becomes important in long-term decision making, like where to build a house, for example. Raya has spoken about that. And then, of course, there is also the enhanced capacity to learn from past damage. So one disaster has already happened, and it has been shown that people with higher levels of education are more likely to actually react on that. In addition to that, more on the social level, there are improvements on general health and physical well-being, but also income is increased, and all of that together should, of course, have an impact on disaster vulnerability. This has recently also been emphasized by a special issue in Ecology and Society. I just want to emphasize some selected examples here, which find effects of education, which I find particularly strong effects of education. Raya and her colleagues have been working on data from Thailand, where they find that villages with a better educated population are more likely to be better prepared and also more likely to anticipate future threats. Samir, on the other hand, using Nepali data, found that there is a stronger impact of education in reducing damage than the impact of physical wealth and income. Frankenberg and et al. Were looking at the pre-tsunami and post-tsunami Sumatra and found that 5 years after the tsunami, the more highly educated are actually also of better psychosocial health. So this is another important dimension of coping. And then there are studies dealing with migration, which show that education is also quite important for opening up that possibility of coping. One study where I was involved personally, it's a study together with my colleague Adelheid Pichler from the University of Vienna, deals with the case of Cuba. Cuba is probably a rather unexpected example when it comes to disaster preparedness, but when you look at the data, you see that in the past, although Cuba has been suffering from quite a high number of natural disasters, just like its Caribbean neighbors, the Dominican Republic and Haiti, if you look at the picture on the left here, the total number of deaths from natural disasters has been far lower in Cuba than in these other two island states. Ever since you see the high red bar in the on the very left side here. This was Hurricane Flora in 1963, which for Cubans, this was right after the revolution, became kind of a tipping point for social change. So since Hurricane Flora had quite a strong impact and caused about 1,200 deaths. There are several different estimates of how many people actually died. But this led to an unprecedented literacy campaign throughout Cuba with very vast social participation. So really in the communities, those people who were able to write and read and write helped those who were not to start learning reading and writing. And within only 1 year, if these accounts are true, about 700,000 people were lifted out of illiteracy. And these important efforts were continued until today, such that Cuba now stands out in the developing world as one of the countries with the most highly educated population. And you can see that here on the picture, in the picture on the right, where Cuba is very far to the right, right on the line describing the linear trend between my education variable here, the share of women aged 20 to 39 with at least secondary education, and the log of the total number of deaths to the initial population. Whereas the Dominican Republic and Haiti lag far behind and have far less educated population. But of course, you have to control for many other covariates. So if you want to look at this relationship between education and disaster vulnerability, and so here I present an updated version of previous results stemming from an analysis I conducted together with Wolfgang and Tony Pett. And as you can see here, first of all, I present 7 different models here because, of course, GDP per capita, infant mortality as a proxy for the health system in a country, and education are quite correlated. And so I present different models where I take different combinations of these 3 variables at a time. And as you can see here, the female education variable is found to be significant in all specifications, highly significant actually, whereas the income variable is not significant in any of these. At the same time, since we are going to produce projections based on these estimations, the main concern has to be with insignificant variables in the model, because these are going to inflate the uncertainty ranges of our projections. And so I end up using model 7 here, also because the model selection criteria down here, AIC, BIC, recommend to do so. So finally, as I recommended, announced at the beginning, I'm applying the results from B to the shared socioeconomic pathways. And what you have here finally is the projected future decadal number of deaths in thousands for the 6 different world regions. These are, of course, still very preliminary results, and I need to look into them more. I need to spend more time looking into them. I haven't really had much time to do that, but you will probably see that there are many kinks here in Europe, for example, but also in other regions. This is because I'm calculated the number of deaths first for individual for sub-regions within these larger SSP regions, and different sub-regions within the larger regions turn from positive growth to negative growth in different decades, and therefore you see these kinks, these breaks here at times. At the same time, there are also some breaks crossings in the trajectories, which is also due to these sub-regions from which I aggregate. Yeah, I'm actually sorry. You were just talking about the importance of disaggregating, and now I'm aggregating everything and even using the national level CRED data. But, later versions of the paper will hopefully be more advanced. Since there are no estimations as of yet on what the different SSPs are going to mean in terms of concrete numbers of future disasters by world region, in this picture, I had to assume a constant hazard, meaning the hazard of the last decade is constant over the coming decade. And this is actually also the reason why you see the number of deaths in Europe to be so much higher than in Northern America, thank you, because in the 2000 to 2010 period there was a tremendous heat wave in Europe which killed thousands and thousands of people, and in addition to that, as you may have seen in the overall population results already, Europe is actually much more than the European Union in the SSPs. It also includes Russia, and so the deaths are much more. But since, according to most serious climatologists, climate change is going to affect the number of extreme weather events, and we are very most likely going to see quite a tremendous increase in these extreme weather events. I also did a very rough job here in calculating the future number of deaths per decade, assuming a very conservative doubling of the number of deaths until the end of the century. I just want to highlight here that even, well, already in the baseline scenario where we assume constant hazard, the range between the very optimistic SSP1 scenario, where people are very resilient, have very strong adaptive capacity, and the very pessimistic SSP3 and SSP4 scenarios is quite large in Africa. But if you assume a stronger impact in terms of the frequency of natural extreme events in the future, then the range of between these scenarios is going to go up enormously. And this leads me to my conclusions. Over the coming decades, as I have said, large amounts of money will have to be spent on adaptation programs, but it's yet not really clear what would be the best way of making, what would be the best use of this money. And what I have tried to do here is to present education as a new policy focus to reduce social differential vulnerability and increase adaptive capacity to climate change. Because as we have seen from the results, from the predicted number of casualties, it is very, very important that the world evolves rather according to SSP1, the very optimistic sustainable development scenario, rather than SSP3, the fragmentation, or SSP4, the inequality scenario. So thank you very much.